displaying the text. And let's see what we got here. So for displaying text, I want, depending upon the state of the game. So basically, if we're not started, I want us to press enter to start the game. When we're playing, nothing to display except it just updates the player. If we win, then congratulations, you won. Press enter to restart the game. And if we died, some snarky comment, and then hey, press enter to restart the game. So let's go ahead and do that. Not started. So what we can do is we can set when we create the game here. We'll set your playing state to not started. Now if we run it, we'll just be standing at the beginning. Okay, perfect. So I want some kind of text up here. And then in our draw, we could probably do that. So we could actually create the text ahead of time, not have to create it over and over and over again here. So let's create and save that text into our main game state. So we can have press return to start, maybe not plain text. And you're going to be a type text, which is off of GGEZ graphics. All right, what else are we going to have? We're going to have a, so I guess not plain could be the first one. We're going to start with that. Press enter to start. And then down in draw, we probably want to match on our state and then basically draw what's going on. So this is drawing the camera, and I'm thinking it's okay to always draw the camera, but we also want to draw any text, potentially. Okay, so if we're not started, I'm thinking, well, so this is the text. I think we want to set its font and do some other clever things to it. Probably want to do that up here. And then I think I can do things like set its font. So not plain text dot. Yeah, we're gonna want, okay, so set font. Okay, then we have to give it a font and we have to give it a scale. So probably just like the default font. And then whatever our scaling is going to be. So scale uniform, it takes an F32, so let's try 72. Is that going to be just just ginormously big? And then not plain text is gonna be just that. Now I should be able to draw this and just send it to its appropriate destination. Okay, so then where do I want you to be? Do I have drop params in here? I don't. Okay, drop param, create the new one, and then we're gonna send it to a destination, which is gonna be a point 2, which we also don't have in here. Okay, so I want it to essentially go like almost to the halfway point. I can probably actually calculate what that is here. Because I think I actually have the, because I have that text, I can get its like dimensions. So I can do self dot plain, not plain text dot, yeah, width, returns the width of the formatted and wrapped text in screen coordinates. Perfect. So tell me what the width is. And that returns just a U32. I could probably do the same with the height, right? Is there one to just get dimensions all in once? Yeah. Okay, give me the text width, the text height. All right, so now I want the exact middle of the screen minus half of the text width. Well, if I'm going to do that, I need the screen size. Okay, that's the X. And then I want to move it up because I'm going to want to like press return to start. No, I guess like we already have that. So this could go straight into the middle. Let's try this. Oh, you're a U32. Can I cast you up here? No, not there. Can I cast you up here? I don't think from will work with a tuple. So let's just shadow. I can mute them. Oh, do you each need to be mute instead? Okay, how about this? We're just gonna shadow them. There, that'll make everything happier. We don't even need the text height here. So I can go ahead and not do that. Underscore U. Then we draw it out and we put it into the center of the screen. So let's see, self.state. Oh, and then non-exhaustive patterns. Then we have to worry about the other ones. Let's not worry right this second. And just do a no op. That doesn't feel like the center of the screen. It feels like it's starting at the center, but then going down. So I do need to bring up the middle of the text by the height. So I do need this. And then for our y, so bring in the middle, minus text height divided by 2.0. There we go. There we go, that's not too bad. Of course, if I press enter, nothing happens yet. We need to now handle that. Okay, so if I want to start playing, we're going to need to catch when we press the enter button and then figure out like what we're supposed to be doing. Handle that input. There is another function off of this event handler here. There's a key down event. And this will give us, okay, we get the context, we get the key code, and we get key modifiers and a Boolean. Okay, so key code is, I think it's off of input. There it is. Key code. And key mods. Perfect, perfect, perfect. So we're gonna have to, it's gonna depend upon what state we're in, right? If we're in, and do we really care? Probably not. The state can care, right? And the state's going to be what changes this. But then again, we ran into the same problem, don't we? How do we like potentially change the state based on this? We should probably just do a match. So if we're in the not started state, then we're really caring to see, is the key code return? And I think I can use key code return just like this. So if we're that, then we're going to change the state. Just like that. And then for these other states, we're just not going to care about them right now. All right, let's check to see if this works for us. Hit enter, and we start playing. So perfect. But now we get into this state. So now we're gonna want the congratulations, you won. Like press return to restart the game. Where is that? Here it is. So this would probably be the same font. So we're gonna care about that, but we're also gonna care about like press enter to restart the game. We can make this maybe a little bit smaller too. Let's do like, I don't know, 64. And store these away. So one text and restart text. Not in there. In here. Okay, so if we won, we're gonna do something probably pretty similar to this. We are going to, okay, so get the text width, but this is, instead of not plain text, this is gonna be the one text. And then we're also gonna want to do the same thing for the, I guess like what we won. Let's see how this will look. So if I do this, and then we're gonna draw out the one, like the text that we did. And that should be fine, except I do want it to go up by maybe like the full amount. So that way I can have the restart text width right underneath it. And so this one start like below and then plus maybe half of this. So that will now like cut that in half. And of course, if we're gonna have like the restart, but that will be its own function. So let's go ahead and just see if this works. Okay, not terrible. You won, play enter to play, press again. Of course, we don't have that set up. So what does resetting look like? Resetting looks like we're gonna take the player, we're gonna change its location back to the beginning and the start of the level. And that's pretty much it, right? Like, yeah, well, we're just gonna take the player and put them back at the beginning, and change the state. Those are the two things. So if I have a function to do that for me, it needs to be able to grab the player. And I could just completely rebuild the level again. So like toss the grid, rebuild the grid, except do we really need to do that? All I actually need to do is grab the player. So get the player and then get that out of there. Now we create the player inside of this populate level. So we don't actually store the player away. So we don't know where they are. I suppose what we could do is in grid create a query for like get like remove object by type, or just remove player. Probably remove object by type. And it will search through the entire grid, find anything that has that type, put them into an array or a vector and return those, and then remove them from the grid. I like that, because then we can just take that, change their location, and reinsert them. So let's go ahead and update the grid. Okay, so we're gonna go ahead and take in the type here. What are you upset about? Oh, because you can't be the type, so it's gonna be game object type. All right, well, standard operating procedure for this: loop down the Y, loop across the X, get all the cells, and then deal with it there. I don't know if I want to take ownership of this. Let's see. But maybe it won't like fully destroy them at the end of this. So that gives me the row, and then I'm going to get the cell. Okay, so now I have the cell, which is a hash map. So for every single hash map, I want to basically do a remove if it matches a pattern in some kind of predicate. And I wonder if there's a method for me. I mean, so there's a filter. I don't want to partition it. I want some kind of like remove. Remove if it like matches. I don't know if we have that. Don't want to take. Okay, creates an iterator that yields elements based upon a predicate. But I don't know if this is going to actually take it out. Oh, and yield elements while it returns true. So as soon as it returns false, it's going to stop going over. So that's not helpful. Okay, so here's nice. Try find applies function to the elements of iterator and returns the first non-none result or the first error. I like this because we know that there's only one player in this game. So I could do a find to get the ID and then use the ID to extract out. Let's do this. So let's try find. So we also need to know like which cell it's gonna be in. I wonder if I can like hold a mutable copy of it off as I go through and do this. I don't think I'm going to be able to because I'm going to be searching through it at the same time. Let's actually just store the X index and a Y index, the Y index. Okay, so that's going to give me the X index and a Y index here. I'm going to want to store these off. So I'll just leave these sort of like preset here, and then if we find it, so this is going to return a result and then an option inside of that. I guess I could match or if let okay. I think I have to handle the error. So we're gonna match on you. If we're okay, that means we're gonna get the option which potentially holds what the thing is. And then I want to, and actually you need to be a function here. So I need to give you an actual function. So what are you? You're gonna be a, let's actually return. There, that'll make these a little bit easier to read. Okay, so our find here. Maybe before I do my game. Okay. Okay, so our try find, we should be able to get like every game object in the cell. Oh, we're gonna get the ID too. And then the game object. And it looks like we're getting a double reference. That's cool. We're gonna want to return a sum if the game object and this is based upon the types, right? So if the game object dot my type. Oh, and of course we can't just do a direct comparison like that because we don't. It's an enum. So if let okay, so if this is that, does that work that way? I mean, in reality, I would just want to return the X and a Y position and then the game object ID. That would probably be the best. So if I return, we wouldn't even need to store these outside of here. I can return a sum, I guess a tuple for right now because I don't have like a struct to hold this. And then the game object ID. What are you upset about? I expected a square bracket. Why is that? What are you matching against? You're matching against that 4. You're matching against that. So you're here. You close. No, that doesn't seem right. Okay, hold on. We open you here, and we close you here. We close you, which opened here. And then you. Let's not do the match right now. Okay, so expected, nothing found results. Oh, try adding additional semicolon. Okay, so right here. Oh no, use of unstable library feature, try find. Well, that's a problem. Okay, so try find is nightly only, I guess. Well, taking me to the standard library. Let's go take a look at hash maps and see. Let's see what we can see here. I mean, there's contains key. If we like kept the key, the ID of the player, we'd be able to. Well, okay, that's not helpful. Contains key is not helpful. We want to actually remove it. Okay, so we probably want to do this as just a plain search. So I don't think we can do it quite as clever as this. We'll have to do a for loop through. We'll get the okay, so that gives us this. And we're not going to be able to manipulate it right here, but we can sort of exit out. Is that completely true? We're going to get the game, like we have access to the game object. If I loop through you as mutable, so for each cell in row, so in cell that iter mute, not you, but you. So now I have mutable access to the hash map. Then, if I find the type that I'm looking at, we're going to remove it and add it to that vector. I wonder if I can do this. So if let, because I don't think I can do if game object type. Although maybe I can with like a just implementing a compare. Yeah, so it's going to say, okay, an implementation of partial equal. Let's go do that. Okay, so you're happy with that. Then we found our type. Let's go ahead and remove it, and we have the ID. And so we're just going to push that in. And I guess we can't straight up remove this yet because it's going to be an option. So let's, I guess, first remove it. All right, so then we get this idea and we use it to remove here, and so now we have an option of a game object. If we actually have a game object from here, which means I can just do an if let straight off of this. All right, so if we have the game object, let's push it into here. We don't need either of you. So we're just mutating that cell, getting it out of there. All right, what are you yelling at me about? Borrow of moved cell, move value cell, value borrowed here after move. So in line 134, we borrow a cell. I don't want to take ownership of cell. I want to take ownership of the thing inside of cell. Oh, cannot borrow row is mutable. It's behind. Okay, so this needs to be an intermute too. All right, so that goes. Okay, so muted that, muted that. Then here we have a problem. Okay, borrow move value cell. The value has been borrowed here after a move. It moved in line 134. So we get this cell here. We borrow it mutably from the row. So we have like cell, 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 cell. I don't want to take ownership of it. So I want to intermute this. Or can I just do iter normally? Cannot borrow cell as mutable because it's also borrowed as immutable. Mutable borrows at 135, and the immutable borrow is at 135, and the mutable borrow is at 137. So 137, we borrow you as mutable. And 135, yeah, okay, so you need to be an intermute. Cannot borrow cell as mutable more than once at a time. Can I like dereference you to just get at the original one, or like, cause like I want, Okay, that works. Can I also say ref mute? No, that only happens somewhere else. So wait a second, I can do this. You'll be happy with this? I mean, apparently not. There's several errors, but there's no squiggly lines here. Game objects is a vec of, okay, so this is a mutable game object. So I actually want the full game object. I don't want a mutable version of it. How do I gain ownership of it? Because when you remove it, okay, it's because I don't have ownership of the cell. That might be a problem here. Because I don't have ownership of the cell, I'm just getting you. Can I clone you? And then we're right back here again. So 135 first mutable borrow, 137 second mutable borrow. So what I'm thinking that I may need to do is like my initial idea. Instead of actually doing the remove at this point in time, collecting together the IDs and the like locations of like where I want to remove this. So let's create ourselves a little struct that will help us out with this. So I want a struct of a like an object location. And this is going to have an X. So let's go ahead and we're not going to remove it here. We're just going to check to see, okay, if the game object type is this, then I want to create one of these structs and throw it into an array. All right, so we're going to have our X, which is the X index. Okay, now I have a vector of these game object locations after this entire loop. Now we're going to have to loop through this. And then for each one of these, reach in and grab it out. And so this will be our if let, I think. Okay. And that gives me the game object here. Okay. And now I have my vector of actual game objects that I can return. Perfect, perfect. So now if I call this, remove by type, and pass it in a type that I'm looking for in here, this is going to be in our reset function. Okay, so now I have a vector of game objects. In reality, it really should just be one of them. And I mean, if there even is more than one, let's just delete it. Let's just only grab the first one out. So I wonder if I can just do player like this. Grab the first. What if I want to move it? Is there something like first? Oh, that gives me an option. Okay. So I have an option with a reference to a game object. Then, if I do have a player, I'm going to want to reset its location and then put it back in the starting area and put it back into the grid. Am I not storing? Am I not storing the game data? I'm not. Let's store the game data away. Oh, and you're not, okay, you're not mutable. That's a problem. I want a, oh, that's weird. I just want a mute I guess I want to ref mute. It's kind of weird how it's displaying that. Okay, so we put their X and Y positions back to where they're supposed to be. And then we're going to change the state. Oh, no, we have to re-add them in. So now you're yelling at me because this needs an actual ownership. It can't just like take in the a reference to this. So I need the actual thing here. So first is giving me an option with a reference to it. I don't think that's really what I want here. So if I do can I extract you out? Okay, I could just do it in two sort of like sets like this. Oh, cannot move out. Move because does not implement the copy trait. How do I like extract out and take ownership, like consume the vector? I mean, I could copy it again, but we've already copied it once. Let's take a look at vectors to see what we can do. Now, our other choice is I could change, let's do this. Remove by type. Let's do maybe remove first by type. If I remove first by type here, then I don't even need this. I don't need you. We are going to want to probably return an option. So in case we can't find it, we don't even need. This is going to be game object to remove. And you're. You don't need to be mutable because I'm just declaring you in this scope. Okay, so if game object type equals this, game object to remove, just assign you to this. Okay, so now we have this game object location. Then down here, we don't need to loop through this. We're just going to and this gives us a sum. So I wonder if I can just here, let's now, I suppose this this could be nothing at all, right? Like it's possible that game object to remove is a none, and then we're gonna be setting this. So we probably want to game object is a sum like this. We'll initialize you to be a none and mutate you. then we'll be able to say, okay, if we have a game object to remove. Okay, we have the game object to remove. Then we want to reach in and return okay. Okay, we've updated this so it just finds the first one. Now, this is not going to find the first one. This is actually going to find the last one. If we find this, I want to immediately break. We set the game objects to remove, and then we break out. So if we find one, this will be set to a sum game object location. If we don't find one, it'll be a none. Then we just check to see here, are you something? Have we found you? If we have, go ahead and remove it and return this. And if you remember the semicolon situation with Rust is, and like ifs, you can actually return from ifs if you want to. So I'm returning out of the if, and then the if statement is returning out of the function. So that's what's going on here. So this gives me an option game data type. Back to you. We're now going to let player equals this, so we can go straight into an if let. Okay, so grid remove first by type, handed in this player, and now we have this player that's a game object. So if we have the player, I don't need to try to extract you anymore, we have you. We're going to set your location, and then re-add you back into the grid. Oh, and we want you to be immutable. And then we add you back into the grid. Okay, that's fine. When we add you back into the grid, we're going to want to also change the state and then tell the camera that the player moved. So that's going to be fun. Now we're not storing the send camera event, are we? But it's stored inside the player, isn't it? It's stored inside the player physics. But here we have this. Player moved event. Send. You are not stored here. So let's go ahead and add that in here too. Okay, so we tell the player tell the camera the player just moved. I of course want to do this before I add it back into the grid. And then we're going to change our state to be not started. And then we want to call reset game inside of here. So if we have 1, like that, and they'll handle changing the states for us. Now we have some errors. Player moved event.send. So let's actually clone it when we send it down here. No errors. Let's see if this works. The camera didn't move. We moved the play. I think we moved the player back, but the camera didn't actually move back there. Now, why is that? I think that's because it's relative position, isn't it? We tell the when we receive the event, we just add by like the player moved by this amount. So we actually need to track where the player moved to in here. So where is that? In our reset. Let's track where the player moved to. So we need the old location X. And then when we send to the player, we want to send, okay, player.location. Wherever they are now, minus wherever they were, minus wherever they're going. So player.location minus old player.location X. I think that'll work. Oh no, that didn't work. Okay. What is that number that we're sending? I'm curious to see, like, is this a really small number and that's wrong? No, it's so negative 1800 pixels. So I actually want the camera to move back by 1800 pixels. That seems correct. So if we go to the camera here, we want self-location X plus equals player.moved X. Okay, so this seems fine here. Are you being received? Okay, so we're moving forward by 6 each time. That's fine. We stop moving forward. That won't let me. Okay. Player location. Oh, okay. So this is source library RS 193. Does it not actually send a message if I don't handle that option? Let's handle this. Maybe there's an error. No, that didn't seem to be it. Oh, I think I know. I think I know. I think I know. The camera. Hold on. Let me take this debug out. I think I know what's going on. Let's go to the camera and take this print line out. I know what's happening. Okay, so in the library, in the update here, we're only updating the camera if we're in the plain state. I want to update the camera all the time. So we should remove you out here. So camera, you always get an update. That way you have the highest chance of handling this. And then this should work. Bam, back to the beginning again, and we can start playing again. So everything is looking good. All right, so we can now reset the game. Let's go ahead and a marker for this. Can reset. Let's see.